Yeah, Russian ierakst. So, okay, my name is Kārlis, and the topic of today is crash course in Tornado Web Framework. This talk will be split into two parts. The first one will be more like generic, what's Tornado, and the second one will be about some real-life examples and insights. So, yeah. Well, what is Tornado? It's a high-performance, quote-unquote, web framework. It's also an async networking library, and it's really lightweight, and it gets out of your way when you're trying to do some non-standard things with it. So it's really easy to use. The community is not hyped. It's not like the N-word framework, which is really popular, and there are a lot of those people. But like Tornado is keeping really low profile, and there are people using it for professional needs. So, brief timeline, it's a relatively new project. It was started in a company called FriendFeed. They tried to solve this problem that they wanted to aggregate stuff from multiple social networks, so they made Tornado just for this problem. They were acquired by Facebook, and then Facebook open sourced the project in 2009, and it's still being actively developed. And the latest stable release was in September, but there is a new major version 3.2 coming up sometime soon, so it's still actively developed. There are a couple of companies using it. Of course, Facebook and FriendFeed, then Bitly and Hipmunk, which are more notable, and the startup that I'm working at called Kobo, and Tornado is running everything backend for us, web apps, API servers, and more. And hopefully after tonight, your startup as well. Installing it is the same as for every other library. Stable version goes simply under Tornado, and unstable version goes with the URI to GitHub and their Facebook account. And this is how the minimum viable program looks like to get a hello world out, and it shows the basic components about which I'm going to talk about in more detail shortly. So you define a handler that gets a request and then does something with it. Then you create a mapping from some resources and those handler classes, and then you initiate a web app, the application instance, and start an IO loop. So, in more details about each of those. So, on the very bottom level of this whole list is the IO loop. It's input-output event loop for non-blocking sockets. It works for one IO loop per thread or per application, mostly for application. Under the hood, it uses equal or KQ, or I think the fallback version is the select, which is the default equal version. So that's basically under the hood. And you can create, you can see that, you can create a really simple TCP server just with this. So you define a non-blocking socket, and then you start an IO loop and give the connection ready function as the fallback to that. And you just send data while the socket is moving on the other end. So this is a really simple example, which is not using any Tornado web app features, just the IO loop. The next step on that is the Tornado HTTP server. It's async web server. It utilizes a single instance of the IO loop, and it's a subclass of TCP server. So Tornado is not limited to use in HTTP. So it's a really simple implementation, and you can create your own web framework based on this HTTP server. And here's a little example with that. You can start a server and give a method that does something with that request, and it's just really simple. It just replies with hello world. And again, you start a server instance, you start an IO loop, and it works. And those are kind of the plumbing tools, so you don't use them in typical apps with Tornado. Tornado application is more of this porcelain tool, if you may. you use them more often in typical apps. So application is just a container for all the mappings from the resource URIs and the handler classes. It is a container for settings as well and kind of just rendering things. And there are a lot of cool things included, like support for virtual hosts. So you can have the same URN but different like URLs, and they can do different things. And the basic building block, or on the very top of this, is the request handler class. So it's the base class for all your request handlers, and the idea is really simple. I'm going to show shortly that you define a class, and you have functions with the HTTP method names, so post, get, put, whatever. And if the method exists, then it's called. If it doesn't exist, the handler raises HTTP 405, which is method not allowed, so it's really simple. And the cool thing here is that you're not limited to the standard verbs. And like I think in Django, at least sometime before, you couldn't really deduce easily whether it was HTTP put or delete. You had to scrape it out manually. Maybe it's changed, hopefully. And so this is what a typical blocking request handler method looks like. If something is wrong, you can raise HTTP errors from there, and the request handler will handle that. And you can create payloads and render things out, and you can fetch resources from like third parties. So yeah, and on the second row you can see how like the mapping looks like. So you have this class and the mapping with some user ID that gets passed in. So there are other things included in there as well. So there's the HTTP client, as I said. There's templating system. There are option management tools. There are generator interface for synchronous calls. I'm going to talk about those shortly. There is alt mixin for auth and like subclass for Facebook and Google. And there are some other batteries included, but it's not a kitchen sink framework. There's just the bare minimum for making three things. Okay, and this was the previous example about a post request that sends some data to MongoDB on the first red row, and on the second row it fetches some data from external resource. So both of those calls are blocking, meaning that whenever some operation is writing data to MongoDB and waits for a response, or it's fetching data from the website, the whole IO loop will halt until the operation is complete. But we can improve that. And the first thing how we can improve that is using callbacks. So you can, with little changes, you can make an asynchronous HTTP client and define a callback method which finishes the post request. And in our case, it just takes a response and passes it to the render function with the results. But there is an even better way, which looks really interesting, and you can use generators for that. So you can grab in the yield statements the functions, and basically what this is going to do is that all of the code that is left and below the yield statement will get executed after the callback the data has been received. And it's really, in this way, it's really easy to transform the blocking code to async code just by dropping some decorators on top and wrapping calls into these yield statements. There is a way to make MongoDB calls async as well. A guy on PyMongo team is making a wrapper for PyMongo, which is called Motor, and it wraps the PyMongo calls and in a similar fashion, so you can do that as well if you need to get a callback back from MongoDB if it's important. So yeah, but there are some caveats using asynchronous calls, and especially multi-threading. So if you have some worker threads and there's an exception raised there, it's gonna either block the whole thread and fail silently, or you can't use it anymore. So you should always raise in a thread which is the main thread, or a thread where an IO loop is running, so it can notify so the error can bubble up. A typical error in development is to forget to add decorators. So if there's not a decorator, the function will not be wrapped in the correct fashion. It's just going to fail silently. And gen tasks are toxic, meaning that if you use it in the last call, you will need to use them up until the top level call. There's also a WebSocket module, which implements the RFC standard. So instead of post put, you add the on message and on close and open statements. Yeah, the end is a bit wrong there. So you can define those in a similar fashion, just assign this echo handler class to the resource /echo, and it will do the same way until this JavaScript client will close out the connection. It's going to echo out all what's passed in there. Yeah, brief about templating. There is a simple templating engine included. It's, as I've seen some benchmarks, and it's really up in just levels of performance with Jinja 2. So meaning it's 2 times faster than Django, or even more. It's easily extendable, so you can write your own filters and your own helper methods and all that. But there are some built-in helpers included for reverse URLs and all the stuff that you would expect. And here's a little example. So you can pass in like a lambda and some dictionaries, and the looping happens like in standard Python code. And you can call your lambda methods that you have passed in there, and it's gonna output the whoa in caps lock. So yeah, that's a really simple example on templating. So if you are familiar with Jinja 2 or Django templating, this won't be much different. And yeah, this was the first part about the theory and how it works. And due to technical resources, I want to give word to Jānis. So meanwhile, back to the point. Yeah, so a bit about testing and debugging Tornado apps. They provide a Tornado testing module, which basically wraps unit test case and the test runners. So transforming your basic unit test files to Tornado, or if you use your modules into Tornado, is really trivial, just using those subclasses. And there are some helpers to test the asynchronous functions as well. And PVB works as expected as well. So there's no, you shouldn't fear the asynchronous or I/O aspect of using this. So you can just set trace and jump through things like you normally do. Okay, that was like more theoretical aspect of things. Now I want to talk about running it in real life. The good thing is about Tornado that the HTTP server that is included is suitable for production. So you can basically run it. You don't need to use any other server, so you can use itself and use like supervisor daemon to manage things. So this is a modified example of how we do things. So you have up to like 2 instances per core. So you can have as many as you like instances and manage them with supervisor daemon. And here you can see just start the server and give the options. In this case, this is MongoDB host and the port number. And then you can load balance it with Nginx like you normally would. Just list out all the app streams that are managed by supervisor daemon. And on the and Nginx, the word of wisdom that I kind of found out is it's really good to serve all static content from Nginx because Tornado tends to be slow with it. So Nginx is smarter on handling static content than everybody else, so use that. And don't block Tornado with unnecessary requests. If you know that this URI will be needed for Tornado, just catch it out on that level. And if you're using Amazon, another word of wisdom is to put ELB on top of that and split stuff between different instances. And I briefly touched in the previous slide that you have this server by, and you keep given like a port number and a host of MongoDB instance. And Tornado provides options on how you can manage this. So you can define options, like in this case you have version number, MongoDB host, and a port. And you can call the command called parse command line, which loads all the data that has been provided in the command line arguments and the stuff or the fallback value that's given in the define method. And the options, much like IO, is a global singleton, so you can use it anywhere in your app. You can call it an initiation of the application or in a method call or whatever. And HTTPS is as trivial as giving like two options to the application would be where is your key file and where is your certificate file. And it will work, assuming that your certificate and key files are valid. And error collection is also one thing that's becoming really trivial because of the standard approach of Tornado apps that you just override methods or implement your own within the request handler. So request handler has a, by default, empty method called send error, which basically you can define the behavior called the error as is sent to the client, and you basically can catch all the 500 errors there and do whatever you want with them. And the Sentry, if someone uses Sentry, I don't, they provide an instance to do that, so you can use the Raven library for that, and they provide some mixins, but I don't like the syntax for that, and it's really verbose in my opinion, so I like the send error method better than this. But yeah, this again is one of the things how you can catch exceptions. So yeah, that's Tornado is a really simple framework and a collection of tools. It's not Django where you have to learn ORMs, and as maybe you saw, there was not a single word about ORMs or things like that, because there's no such thing in there. You can choose your own or choose none, and you can structure your apps like you want, and that's basically your freedom. And as the Tornado app has a standard entry point of the file where the application is initiated and started, all the apps are easily traceable. So there are no surprises or defining on what's where. So yeah, that's about it in a nutshell.
Okay, I have questions.
Yeah.
First, have you used Tornado with VHGI, like together, for example, with Django or Flask?
No, just in the setup that I had described, just it's hooked under Nginx.
I know it's possible, but I haven't done.
So yeah, I haven't used. They provide some modules for that. You can use VHGI with that, but I haven't used them because there's no need for me at least. But there are some things to check out.
Is there any ordering of callbacks? Meaning that if you define two callbacks in a row, that they will that main event loop will skip one, so that order is defined.
Well, it all depends on how you define methods, because you pass in a partially applied method in there and that's it. So it all depends on that. That's how it works basically. But the callback approach can lead to early pyramid style code when there is callback, and I heard you like a callback, then there's another one, and that's it, like, in this triangle shape. So the generator approach is so much better and more readable. It first looks a bit magic at first, but it's a better way to use, I think personally.
How do you deploy Tornado through an engine?
For me, it's really simple. You zip it up, copy out all the upstreams, make like symlinks in place, and incrementally restart the supervisor groups. Because Nginx just checks on the port whether it's up or not. If it's an upstream, it's gonna try to use another one or on another instance, so you can have like fallback upstreams. So it's basically incrementally restarting them slowly, and it starts up really fast, so it's not a problem in back and forth.
I'm just sorry that Nginx is not so good for asynchronous servers.
Well, Nginx is just for routing the server itself, and the callbacks and all that is handled by the Tornado. So Nginx is just as a load balancer and as a proxy on top. Yeah.
If you're not doing any asynchronous operations in your application, is there any good reason to use Tornado?
Well, it depends. It's lightweight, it's fast to make it, it has a low footprint, so you know, it all depends on your preferences, but it reminds me of Google App Engine when it was good in the way how the base app is structured. So, well, initially when I started working on Tornado, I made apps without any asynchronous code in them. It was just, I liked the way how it's all structured. So yeah, it's all about choice and your preference.
Yeah, I think I have the opposite. It's a bit hard to structure it if you have your own, typical web application with many endpoints and many different rows. Then, as is how you define a class, and then you define like a post method handler, get method handler, and so on. I kind of found it out. Well, I find it easier, like the Flask approach, where you just wrap it with a decorator and tell it that okay, this method accepts post or get, or just one of them.
But you can,
You can probably hack it.
Well,
That's personal.
it's basically one of the ways how I structure things is with mixins, so you can have your basic, if you need a landing page, you have whatever mixin that you drop it in, or make a base class with some validation methods and all that, and just organize it that way. So yeah, it's all about preference. So.
If you have boss and boss would say, oh, okay, why Tornado is better than Node.js? What did you say to him?
The good thing for me was that my boss said that Tornado is better than Node.js, so that wasn't for me. But I don't know, it's all about, I think, religion maybe. If your boss thinks that JavaScript is a rock solid infrastructure that you can depend on, why not? So,
No, I just want to know why you think Tornado is better.
because Python is better. It all boils down to that basically. It's all preference, I think, because I like personally Python better, writing Python than JavaScript in many occasions. So that's.
You haven't done any performance test or something like that?
Tornado single performance test comes out very close to the top as much as I've seen it, but those benchmarks were mostly just empty loops, doing nothing.
Typically,
Very fast at doing nothing. I don't know how fast it is doing something.
typically Node is faster than Python, though. So probably
Yeah, if you want to really go for performance.
Yeah, I mean,
If
that kind of benchmarks are your bottleneck, then you probably should
Doing Chrome.
move something. Yeah.
So it's choice and religion.
Was there any particular problem you guys were trying to solve in your company that you chose Tornado over a traditional, web server like Unicorn?
Yeah, the typical problem was we had different sources that we needed to fetch data and do it, as fast as we could, and then proxy it through. So it was basically it fetched data and proxied it further.
Why wouldn't you use like just a queue architecture?
Was that?
Why wouldn't you use a queue architecture for something like that?
Well, because we needed the data ASAP, and the queues and delay, we needed to proxy it through immediately, so it was a good fit for that. And yeah, that's basically it. Okay, any other questions?
I think we all need to just touch it.
Yeah, I'll put all the code samples on GitHub so they can be hackable. The installation is just one package and it's pretty small, so yeah.
I just want to remark is that there is a book on O'Reilly about developing on Tornado apps, so I highly suggest.
Well, what I highly suggest, if you are serious about Tornado, that source code is really well organized, and it's just, I basically learned it that way. If something doesn't work, you just go through the source code and hack it together. So, because the amount of boilerplate is really minimal, so you can see how it works really fast. So.
And related to the source code, is it pure Python or does it have?
Okay. Well, thank you. And I think that about wraps up the formal part of this meetup. So now it's, I think, pizza time.
Yeah.